Hello everyone. Let us start the lecture. We are going to discuss about Towers of Hanoi puzzle using recursion. Towers of Hanoi puzzle is a famous puzzle from discrete math and we are going to use recursion for it. What is a recursion? It is a fundamental concept in programming and mathematics where a function calls itself to smaller instances of the same problem. What does that mean? Let me explain that by taking one example, very easy example. For example, you need to find 5 factorial. What you do? You do 5 into 4 into 3 into 2 into 1, which can further be written as 5 into 4 factorial. So what basically I did for finding 5 factorial, I am using 4 factorial. Further, I can use this one, 5 into 4 into 3 factorial. Now for finding 5 factorial, I am using 3 factorial. This is the process of recursion. Why? Because for finding a function value, I am using the same function value for some different n. Now here we need to understand two cases, two things. One is the base case and other one is the recursive or base step or recursive step or recursion. What this base case is all about? So this 3 factorial, if you further simplify it, you are going to get 5 into 4 into 3 into 2 into 1 factorial. We all know what this 1 factorial is. It is 1. So this particular 1 factorial is equals to 1 is considered as the base case. And what is the recursive case? It is nothing but f of n, where f is a factorial function, is equals to n into f of n minus 1 for n greater than or equal to 2 is the recursion or recursive step over here. Let us understand what the Tower of Hanoi problem is actually all about. Yes, let us talk about the actual puzzle now. What this puzzle is all about, this is called as the Tower of Hanoi puzzle. As you can see here in the figure or here in the diagram, which has been taken from Wikipedia, you can see 3 pegs are there or 3 towers are there, 1, 2 and 3, and some discs. Let us say how many discs? N discs are stacked in any one of the tower. The task here is to move all those discs into some other tower, let's say tower number 3, such that the sequence or the style of disk should be undisturbed like this. That means the disk with the smaller radius must be at the top and with the larger one must be at the bottom. But there are two conditions here. What are the two conditions here? First one is, while doing the transactions or while doing the moves, you are allowed to move one disk in one transaction only, one disk at a time. Second condition is, you are you are not allowed to put the disk with smaller radius below the disk with larger radius. Okay, so this should not happen that there is a smaller radius disk and there is a larger radius disk sitting on the top of this. No, never. Okay, so these are the two conditions. But what is the question now? The question is, what are the minimum number of moves required to move all these n disks into the other peg or other tower? I hope the question is clear. So always a good mathematician will break down the problem of n disks into smaller number of disks. In my case, I have broken down the problem into n is equals to 3 so that we can think it clearly, positively, model it mathematically, and then we can generalize it. Let us talk about 3 disks over here. Now, if you can see, 3 disks are here and we need to take all those 3 disks over here such that the disk with the larger radius or the greater radius must be at the bottom and that with the smaller one must be at the top. What to do? Let us see. Yes. So how one can think over here? Here we have how many disks? 3 disks. Let us say n is equals to 3 disks. We are supposed to break down this problem into first n minus 1 disk. We need to shift on the other rod. Naturally, this is not going to happen in one step, but some number of steps are required. We will see when we will get into that. After this, because this disk is free to move now, straight away we are going to take that disk over here, and then again these n minus 1 disk, that means n minus 1 is equal to 2 disks, we are going to take over here. Once again, naturally not in single step but in some number of steps. Now what exactly, how many number of moves that we need? Naturally, just not moves, but the minimum number of moves that we are going to require over here. Please listen here. First, we are going to take this top disk over here. So how many moves? One move. Okay, you just count the number of moves. Then this disk is free to move now because this one is removed. Take it over here. So how many moves? Two moves. Now this is the disk with smaller radius which goes over here back again. So we did that. That is going to be three moves, and the picture looks like this after three moves. Do you agree? Right? Now taking this the bigger disk onto the last rod 3, third rod, which is going to be my fourth move, and naturally this disk, the top disk, goes over here. That is going to be the fifth move. The green disk goes over here. That is going to be my sixth move, and then finally this disk goes over here. That is going to be my second move, to get the picture like this. So for n is equals to 3, how many moves that we needed, the minimum number of moves that we took? It is 7 moves. But it was very difficult. I would not say difficult, but it is unnecessary time consuming to check for each and every disk. Rather, it will be good if you can formulate it mathematically and give a general result which can do the trick for any number of given disks, isn't it? Let us see. Now here comes the mathematical part of it. Let us try to identify the pattern. So I have made a table over here where n, the first column represents n, that is the number of disks naturally. And of course it can be more than 100 also, but I have kept it. I have put some upper limit to that. And the minimum number of moves that is there. Just now we have seen the case for n is equal to 3. Of course we have not discussed the case for n is equal to 1, but it is very easy. For example, if I want to draw it like this, let's say we have 3 towers and how many disks? 1 disk. That means this is the case of n is equal to 1. How many minimum number of moves that we are going to require? Just keep this disk over here. So moves are going to be 1. Only one move is enough, that because minimum number of moves. So for one disk, one move is enough. For two disks, for example, now if n is equals to 2, how many moves are required? You first move the disk over here, you move the disk over the below disk over here, and you again move the disk over here. So your moves are going to be 3. Do you agree? And I am, instead of writing m as moves, I am saying t of n is the number of moves that I am going to discuss, where t is the minimum number of, या फिर minimum moves. Okay, right. Just now we have seen this case 2 is done, 3. Just now we have seen this case that 7 moves, minimum number of moves are 7. Remember, these are minimum moves and maximum can be anything. It could be hundreds, lakhs, thousands, crores as well, but we believe in the optimality thing, so we are talking about the minimum number of moves. Can you tell me what is the minimum number of moves for 4 disk Hanoi problem? Naturally, we can identify a pattern over here. Could you tell me that pattern? That pattern is clearly saying whenever you are trying to find the minimum number of moves for n disk problem, like for example this one, you just refer to the previous answer for the previous number of disks, and don't you think that it is going to be something like this? It is going to be 2 times t of n minus 1 plus 1. Do you agree with this? You can see 7 is equal to 2 into 3 plus 1. Of course, it is giving the answer. 3 is equal to 2 into 1 plus 1. Yes, it is giving the answer. So this is nothing but the recursion या फिर the recurrence relation or recursion. Now, just now we have discussed on the slide number 1 only. For every recursion, there is going to be some base case. What do you think is going to be the base case over here? The base case is going to be t of 1 is equals to 1. That means for moving one disk, we are going to need only one move. That is this one. So I am saying that this is my equation number 1 and this is my equation number 2. On the next thing or the next slide, we are going to solve this recurrence relation to find the actual formula of Tower of Hanoi. Let us see. So what was the mathematical model that we got from the previous slide or from the pattern recognition? It is total number of moves required for n disks is twice the total number of moves required for n minus 1 disks plus 1 with the base case of what? With the base case of t of 1 is equals to 1. That means one move is required for the case of one disk. Let us solve this recurrence relation or let us solve this recursion to get the conclusion of Tower of Hanoi, the answer of Tower of Hanoi. Keeping the left hand side as it is, we can expand right hand side like this. 2 times n minus 2 plus 1 plus 1. Does it make sense? 2 square t of n minus 2 plus 2 plus 1, which can be written as 2 square. Further, we can elaborate it like this: 2 times t of n minus 3 plus 1, then bracket close, plus 2 plus 1. They were already there. Finally, 2 cube. Now we can get the pattern here. It is t of n minus 3 plus 2 square plus 2 power 1 plus 2 power 0. Do you mind if I write like this? Now we are going to continue in the similar fashion, and after how many steps? After n minus 1 steps, where we are going to reach? We are going to one step, two step, like 2 power 1 step, 2 step, 3 step, and so on up to after n minus step. I am going to get 2 to the power n minus 1 over here. And what we are going to get over here? N minus 1. That means n and n will get cancelled. T of 1, which is our base case, which is given. T of 1 is equal to 1. Let us see. Plus remaining things will be 2 to the power, because we did it for the n minus 1 times. Here we can see this 2 is 1 less than this 3. So it is going to be 1 less than the original one. 2 to the power n minus 2, 2 to the power n minus 3, plus and so on, plus 2 to the power n minus n, which is 0. Now rewriting it finally, it is 2 to the power n minus 1, because t of 1 is going to be 1 only, so it is not going to contribute anything, plus 2 to the power n minus 2, plus and so on, plus 2 to the power n minus 1 means 1. Don't you think that this is a geometric series? Right? It is a geometric series with a, that means first term as 1 and the common ratio as 2. And what is the answer for the geometric series? It is nothing but finally 2 to the power n minus 1. That is what the solution that we got over here. Now how to interpret this solution? Let us see on the next and final slide. So far the story is we have modeled the Tower of Hanoi puzzle by the formula T of n is equals to twice Tn minus 1 plus 1 with the base case of T of 1 is equals to 1, and recently we have solved it explicitly by giving the formula T of n is equals to 2 to the power n minus 1 minus 1. This formula is the perfect and explicit formula to give the minimum number of moves for the Tower of Hanoi puzzle for n disks. Whatever may be the value of your n, whatever may be the number of disks that you can have, 100, 10, 100, 1000, 10,000, 1 lakh, or even more than that, this formula is going to give you answer in few seconds. That is the beauty of this formula. All right, we'll stop here for today and we will discuss some other topic in the next class.